The radar cross-section, RCS, depends on several factors. First, the RCS will depend on the frequency of the electromagnetic wave, or microwave energy, that's being emitted and reflecting off the target. You'll see later, when we look at a simple sphere as the target, that the frequency plays a significant role. We introduced the concept of polarization in the introduction, which refers to the orientation of the electric field vector. The RCS will depend on this polarization. It also depends on the target's characteristics, such as its size, whether it's a good conductor, made of metal, or if it absorbs parts of the electromagnetic radiation. The size, shape, material, and orientation all matter. For instance, if you have a long, cone-shaped object like a missile, the RCS will be smaller if the object is pointed directly at the radar, since less area is exposed. On the other hand, if it's broadside to the radar, more surface area will be intercepted, leading to a larger RCS. Another factor that can influence the RCS is the location of the receiver. There are two types of radar operations. Monostatic radar. The transmitter and receiver antennas are located at the same place. Bistatic radar. The transmitter and receiver antennas are located at different places. You may remember from the first lecture when we discussed the World War II chain-home radar system, where one set of towers transmitted the radar waves and another set of towers received them. That's an example of a bistatic radar system. Today, most radars are monostatic, but bistatic radar systems still exist. When designing a bistatic radar system, it's essential to consider the bistatic cross-section. This cross-section depends not only on the orientation of the object relative to the radar, but also on the orientation of the receiver. This adds complexity, as you have to account for both the transmitter and receiver positions relative to the target's orientation. As a result, the bistatic cross-section is much more complex compared to monostatic systems. It's not just a single cross-section value. You'll have different values based on various angles and positions of both the radar and the receiver. Lastly, in most radar systems, the radar is far away from the target. In these cases, we compare the size of the antenna to the distance to the target. When the target is far away, we call this the far field because the wave that hits the target behaves as a plane wave, as mentioned earlier. However, when the target is near the radar, like a missile with a radar seeker in its nose, it enters what we call the near field. In the near field, the cross-section changes because the target experiences electric fields from different angles of the antenna. In contrast, when the target is far away, it only experiences the field from one point. There are many factors that determine the RCS, but these are some of the primary considerations.